All right, welcome to The Explainer. Today we're diving into a pretty radical new theory, one that suggests the prime numbers we've always thought were random might actually be part of a hidden code.
You know, for centuries, mathematicians have pretty much agreed that primes are scattered all over the place without any real pattern, kind of like cosmic static. But what if they're not? What if all that chaos we think we see is really just an illusion, hiding a deep underlying order?
And that is the fundamental shift in thinking we're getting into today. This new theory asks us to stop seeing primes as just random points on a line, and to start seeing them as stable anchors in a vibrant geometric field.
So how does this all work? Well, it starts with a completely new tool, a new way of looking at numbers that doesn't hunt for factors, but instead actually deconstructs the number itself. It's a method called recursive subtraction. So instead of a computer just trying to find factors by brute force, this algorithm systematically peels a number apart, layer by layer, almost like an onion, to get right to its core harmonic structure.
So this whole process breaks a number down into a few key components that turn it into a dynamic system. You've got the number itself, obviously. Then you have a harmonic base that kind of acts like a tuning fork. And then there's the residuum, which is basically the leftover piece after peeling a layer. It measures how out of phase or out of sync the number is with that base frequency.
And here's how it works. The process is just repeated, moving down through different resolutions. You can think of them as octaves of the number. And each step reveals deeper and deeper structural information, getting closer and closer to its fundamental frequency. Okay, so when researchers actually applied this method, they didn't just find some neat math. They found something completely unexpected: echoes, these persistent repeating signals that were just hiding inside the numbers.
So take the number 24,257. As they peeled it back, this one value, minus 319, just kept popping up, over and over. It was like a harmonic resonance, this little echo that just wouldn't fade away.
And this just illustrates the discovery perfectly. I mean, for 6 consecutive layers, 6 different octaves of resolution, the residuum stayed constant, locked in at minus 319. This was the proof. The number wasn't just some isolated point. It was part of a harmonic family, vibrating at a very specific frequency.
And then, bam! The moment that chain of echoes finally broke, a symmetry point was calculated. At that point, it just revealed one of the number's prime factors, 127. It wasn't found by searching. It was revealed by the structure of the number itself.
So, what does this all mean? Well, this discovery implies something much, much bigger than just a new factoring trick. It suggests that numbers themselves might exist within this vast, energetic field of waves.
And this is the core idea of what's called the prime scalar field theory. It says that primes aren't just scattered points. They are stable, anchored points in this field. And the gaps between them? That's not empty space. Those are wavelengths, and they're carrying information.
And get this. This field has this amazing fractal-like structure. Just like how we peeled back the layers or octaves of that single number, the entire field shows patterns repeating at different zoom levels. You have multiple layers of information encoded at different resolutions, all at the same time. So, here's the kicker. When you analyze all the oscillations of this entire field, a stable internal heartbeat starts to emerge, a supercycle of about 2.34. And what that suggests is that the field actually prefers closed circular geometries over simple straight lines. Okay, so if primes really do create a geometric field, is there any way we can actually see it? Well, thanks to a series of absolutely stunning visualizations called Zara renderings, the answer is yes, we can.
Now, these renderings, they aren't just abstract art. They are direct translations of the raw numbers into visual geometry. And they reveal these incredible structures. You get nodal lattices where the waves all align perfectly, and you see concentric rings, which is more evidence of that preference for circular shapes we just talked about. They also show something called a hyperloop esopulse, which is basically a dense burst of thousands of overlapping waves.
So let's go back and look at the hyperloop pulse for our number, 24,257. Each one of those spiky radial lines you see is a visual of an oscillation driven by a specific residuum from our earlier calculation. It's like seeing a snapshot of thousands of ripples overlapping at once.
And right there, at the very center, you see that dark core? That is the visual proof of the math. It is the nodal point, the exact spot of perfect symmetry where that chain of -319 anomalies broke and the prime factor, 127, was revealed.
Now, this is way more than just a mathematical curiosity. If primes really are a geometric code, then understanding that code could have profound implications for technology, and maybe even for our basic understanding of physics. And here's why this is such a big deal. In cryptography, instead of just relying on how hard it is to factor big numbers, we could use interference analysis. For AI, we could move beyond just statistics and maybe build systems that reason using a kind of harmonic logic.
Yeah, the potential impact here is just massive. This new understanding could revolutionize everything from post-quantum security and data compression to the development of harmonic AI and maybe even our models of quantum gravity.
So we'll leave you with this final thought. If the most fundamental numbers in mathematics aren't random after all, what else have we been looking at every day without truly seeing the hidden pattern, the underlying harmony that's been there all along?